Good afternoon, folks. What I wanted to do today is just take a quick minute to go over one of the more difficult concepts, which is going to be on exam 3. And we're looking at the factors that influence fluid movement at the capillaries. The term we give that is bulk flow. And so kind of give you a little bit of a reference point of what we're looking at is we're taking a look at the movement of fluids which is occurring at our capillaries. And the capillaries are the smallest blood vessels in our body, and they're going to be the point at which we are exchanging fluids between the cells of our body. So to give you kind of a little reference point, if I were to draw out our capillaries, so I'm just looking at maybe the circumference of just one of these little vessels. Okay. So we say that they're in direct contact with our cells. So I'm going to draw a little cell right out here, and he's going to be a hungry guy that's going to need a lot of oxygen. And as it's performing all of its metabolic processes, it's going to be giving off waste products like CO2. So the way that the capillaries are really important is that they're going to be delivering fresh oxygen from our arterial end, and it's going to be picking up CO2 from our venial end so we can have homeostasis and so we can have a healthy environment for our cells. Okay, so what I'm going to do is I'm going to be using kind of a worksheet that I've prepared for you to kind of break down the steps of bulk flow. And you could find this worksheet on Blackboard. It's under the extra exam prep folder for exam 3. So what I've found is that, the concepts itself with bulk flow really are truly not too challenging, but where students get confused is when they look at notations like this and they kind of get overwhelmed and don't know where to start. So I just wanted to break it down into some simpler steps. I have a couple rules that I like to follow when I'm understanding these terms, and I hope you'll find that this will kind of simplify the material for you. So to get started, I just want to go over a little terminology. So the first definition I want to refer to is called ultrafiltration. And what ultrafiltration is a movement of fluid out of the capillary. So the smallest blood vessel is our capillary. So in this case, it's going to be occurring at the arterial end. Okay? And our next term is reabsorption. And that's going to be the movement of fluid in the capillary. And this is going to occur at the venial end. Okay? So, as blood is being circulated, if we're looking at our systemic circulation, we see that blood is going to be going out of our arteries, which is going to branch into smaller arterioles, and then we're going to end at the arterial end of our capillaries. So that's where oxygenated blood is going to go out and deliver oxygen to our cells. So fluid is moving out of the arterial end. And I'm a lousy artist and apparently not very good at Microsoft Paint, so just you have to forgive my lack of artistic skills. Okay, so as we are looking towards the other side of our circulation, we see that if we're in our systemic circulation, deoxygenated blood is returning back to the heart. So we have our venial end of our our venial end of our capillaries, which are going to be picking up waste products like CO2 and taking it back towards the heart. So we see that they merge into smaller venules, which merge into larger veins, and now we're back at the right side of the heart. Okay, so let's take a look at the forces which are dictating the movement of fluids at these different ends. And we have two real forces involved, and we've learned about them before. So the first force that we're going to look at is our osmotic pressure. And our osmotic pressure, we say that it's a sucking force. How do you remember that? Just think osmosis. Yeah, it sucks. Okay? And then we look at our hydrostatic, or our blood pressure. And we're going to say that it's a pushing force. Now, the way these forces are written, we have kind of a special notation for each one of them. And osmotic pressure, this sucking force, we're going to designate with this pi symbol. And our hydrostatic, or our pushing force, we're going to represent with this uppercase letter P. Okay? Why? It doesn't really make sense. It just, remember, big P is referring to hydrostatic, or a pushing force. So just think of big P pushing. Okay? So how I have understood and kind of come to grips with these different forces is I like to think about them occurring in terms of boundaries. So you can think about our blood vessel. So we're looking at just one portion of our capillary. So with our blood vessel serving as our boundary, let's take a look at the terms we use to define whether it's occurring outside the vessel or inside the vessel. Our first one being our interstitial fluid. So our interstitial fluid is referring to the fluid outside of the vessel. You can think of our interstitial fluid kind of like our extracellular fluid, or our ECF. It's just going to be the fluid outside the vessels. Then, when we're talking about forces which are originating or being located towards the inside of our vessel, we actually have two different terms for them. We have our capillary and our plasma. So in this context, we're talking about forces which are originating inside of the vessel. So if that gets kind of confusing, what I like to come back to is look at our interstitial fluid. Interstitial fluid is always going to be referring to outside the vessels. And if you forget that capillary or plasma are referring to inside the vessels, just think, okay, IF, outside the vessel, I got it. So now let's put this all together. Is it a push or a pull, and is it occurring outside or inside the vessel? So let's take a look at the inward forces which are occurring at the venial end. Our first is we have our interstitial fluid hydrostatic pressure. So this is going to be a pushing force originating outside of the vessel. So as we have blood circulate, some of that kind of wells up within our tissue spaces, and it's going to be pushed back in. So this interstitial fluid hydrostatic pressure is going to move fluid inside the vessel. Next, we have our plasma osmotic pressure. So it's a sucking force originating inside the vessel. So we always say that for osmosis, water goes towards a higher solute concentration. So you can think about our solute in this case maybe being like a plasma protein that's staying inside the vessel that's going to be sucking water in towards it. So if we have a sucking pressure located inside the vessel, fluid's going to move in. Okay, so now if we look at the factors that moves fluid out of the arterial end, we'll see we have two more. Our first one being our capillary blood pressure, or our capillary hydrostatic pressure. And we write that as P sub C. So it's a pushing force originating inside the vessel. So as a result, it's going to push fluid out of the vessel. So our capillaries are kind of porous, and as blood is circulating, it's exerting a hydrostatic or a pushing pressure, and that causes fluid to move out. Our last force involved is going to be our interstitial fluid osmotic pressure. So if we have these solutes that are floating around outside the cell in our interstitial fluid, it's going to exert an osmotic pull. So it's going to be sucking fluid towards it. So fluid's going to move out of the cell. And I hope this is starting to make a little more sense. So if we kind of bring this all together, we're left looking at the net forces that are occurring at the capillaries. So we say that our outward pressures minus our inward pressures are going to give us our net movement of fluid at our capillaries. And what we end up seeing is that we actually have more fluid moving out the arterial end than coming back in the venial end in a given day. So as a result, if we didn't have any regulatory mechanisms involved, we'd have a lot of extra fluid building up in our tissue spaces. And some of you have probably seen what's the result of that going to be in an individual where we have this imbalance. So if you ever see somebody with swollen ankles or edema or swelling, it's usually due to an imbalance that's occurring in our capillaries. So lucky the human body is pretty remarkable, and we have kind of a regulatory mechanism that regulates our fluid exchange, and that's our lymphatic system. It acts kind of like a vacuum that's going to suck up extra tissue fluid that has occurred as a result of this excess pressure occurring in our arterial end. And so it's going to suck up all this extra fluid, return it to our cardiovascular system, and as a result we have homeostasis occurring. So I hope this video gave you a little clarity into the mechanisms that are occurring at our capillaries. And at this point, what I'd recommend is working your way through your study guide that Professor Wallace posted. She has a lot of great questions that you could see on the exam. Also, maybe take a look at your practice test or any chapter mini quizzes. There's a lot of resources on Blackboard for you to get ready for the exam. And of course, if you have any other questions, please feel free to email me or see me after the session that we're going to be having to get you ready for exam 3. So, good luck studying. I know this is on YouTube, so don't watch David After the Dentist too many times. Try to stay on task. But I wish you the best of luck, and good luck on Monday.